So what we're going to do is we're going to start by finding the area of a surface area of a hexagonal prism. So I'll find the area of one base, multiply that by 2, and then also find the lateral area, make that a whole total to find the total surface area. So first thing I'm going to do is I'm going to use this formula for the area of a hexagon. It's 1/2 AP. This works for any regular polygon, but we have special things that we can do with a hexagon. So I already know that my perimeter is 84, so I can go ahead and substitute that in for my perimeter. The next thing I need to know is that the apothem. So when I talk about this, my apothem is here. So what I can do is I know that all the way around is 84, so that must mean that each one of these is 14. 84 divided by 14. 84 divided by 6. So if the whole thing is 14, 14, 14, I know that this little half of it is 7. And because I have a 30, 60, 90 triangle here, I could say that my apothem is 7 the square root of 3. So I'm going to go ahead and plug that in. And I'm going to take half of 84 first to give me 42, 7 the square root of 3. And I'll only multiply this 42 and 7 together to give me 294 the square root of 3. In the next section, I'll find the lateral area. So the lateral area is, I could do each one of the sides, like the lateral area is this, each one of these. I could do 14 times a height of 48, and I could do that, and then I could do 6 of them, and that's totally okay. It doesn't use the formula, but that is a logical way to do it, and as long as it's a logical way, you can get credit for it. So this would be 6 times 672, which would give you 4,032. Now, if we were doing it by the formula, it would just be 4. The perimeter, which is 84 times the height, which is 48, and still that gives you 4,032. Now, when I find the total surface area, it will be 2 of the bases plus the lateral area. And I'm going to write the 4,032 out in front because sometimes our square root sign gets a little crazy. So then this gives me 588 the square root of 3 units squared. Next one says if the height of a prism is doubled and the bases are unchanged, what happens to the volume? You could do a prism 6, 4, and 5, and then double the height like this, and do 6, 4, and this is 10. If I were doing this, this volume is equal to 120, and this volume is equal to 240. So I see right now that the volume has been doubled. Another way to do this is to take the volume of the first one, length times width times height, and then the volume of the second one, length times width times 2 height. So because this is multiplication, it doesn't really matter what order I multiply in, so it would be 2 length times width times height. And when I compare this to the original volume, I have doubled the original volume from here to here. And the last one on this page. The idea here is that I want to say, for this much volume, how much surface area would I need? And for this amount of volume, how much surface area would I need? And which one is the better deal? So here we go. I'm going to find the surface area of this one, and I'm going to use the formula. So 2 times 3, 6 times 3, because this is my base, plus 9 times 6 plus 3 plus 6 plus 3. This is the perimeter of the base. Here is the height. So this gives me 2 times 18 plus 9 times 18, which gives me 198. If I wanted to find the volume, the volume is equal to 3 times, oops, a week, 3 times 6 times 9. It doesn't really matter what order you multiply in. So that gives me 162. This one is units squared. This one is units cubed. Now let's say that for every unit of cardboard I use, because this would be my cardboard surface area, it's $1. So I have 162 units cubed for $198. Therefore, this is equal to, if I divide it, this makes it $1.22 per ounce if you wanted to say that we're measuring in ounces, the volume in ounces. Okay? So now I'm going to find the other one. So for this one, my surface area is, and I'm going to skip through some of the formula. I'll set it up. 7 times 2, because that's the base, plus 9 times 7 plus 2 plus 7 plus 2. And I'll write that in a little darker. So this gives me a surface area of 190 and a volume of 126. So let's say that my surface area, when I'm doing this, is units squared. Let's say that every surface area, because that's my box that I'm trying to enclose, cost me $1. So this one is going to cost me $190 worth of cardboard. And I can divide this by 26 ounces or units of measurements, whatever. And this one cost me $1.51 per, we'll say, ounce. So which one would you rather do? $1.22 per ounce or $1.51 per ounce? Probably $1.22 per ounce. So box A is the better deal. And if you think about it, I had 198 surface area and 162 volume. This surface area was only 8 less, but I got a lot less in my volume. So that's how you do that.